R times I.
Yeah, that is true. That is true, but the EMF of a battery, to find the EMF of a battery, you go and measure. The way you said it, it's correct if you're calculating it. You go and measure the potential difference across the battery when the switch is open. You agree?
Yes, sir.
So that is the definition of the potential difference. It is the voltmeter reading across the battery when the circuit is open. This is an open circuit. That's an EMF. So what is the potential difference or across the battery? The potential difference. Now the potential difference is the work done to move charges between 2 points. 2 points in a conductor. So if you have a circuit like that, the potential difference, the reason why we put a voltmeter in this orientation is we are trying to measure the potential initially. Mr. Kumalo. Yeah, there's a problem. Yeah, no problem. No problem. Okay. Sure. Okay. The reason why it's called a potential difference is if you use your voltmeter, it will measure the difference between the potential from one point to another. It will measure the potential difference between these 2 points, because within these 2 points, because you have an electromotive force, there will be charges flowing through the conductor. That's what a circuit is all about. A circuit is all about charges moving inside a conductor. Now, the definition of a potential difference is that V equals work done divided by Q. It's one of the formulas that you might get on your question papers, but you must have it in mind. Okay, no problem. Let's leave that. Let's go back to where we left off. Okay. In what? Okay, waves. A water wave, which turned out to be a transverse wave. Now, in what direction is a particle at B about to move? In what direction?
Upwards, sir.
Upwards, you are right, because the slope is positive. Okay. I like how you figured out everything in this chapter, but yeah, that's impressive. Okay. How many wave cycles are shown in the diagram above? How many wave cycles? How many wave cycles?
I think it's 2.
It is 2, ne? And up until here. You agree?
Yes, sir.
One wave up to there, then another wave up to there. Now, how do we accommodate for that portion? Is it half or is it quarter of a wave?
It's a half.
So we have 2.5. 2.5 cycles. You have to count that half, eh? If it was a quarter, then you were going to say it's a quarter. Okay. A water wave passes a point at a rate of 5 complete wave cycle per second. If the wavelength is 75 millimeters, calculate the frequency of the wave. How do we calculate the frequency of the wave? What is the frequency of the wave? And what is the definition of frequency of the wave?
The number of wavelengths passing a point on a wave.
Okay. So if you check on the graph, they said here a water wave passes a point at a rate of 5 complete wave cycle per second. So how do we calculate the frequency now? Number of waves that passes a point per second over change in time. So how many number of cycles or number of waves?
2.5.
You see, they did stipulate it. Do you see?
Yes, sir.
5 over per second over 1 second. So we have 5 hertz. Do you see?
Yes, sir.
Okay. The second question says, what is the speed of the wave? How do we find the speed of the wave? That should be very easy. How do we calculate the speed of the wave? Which formula is coming to your mind? You don't remember the formula?
No, sir.
The speed of the wave equals frequency times lambda. I don't know if you remember.
Yes, sir.
You don't remember? V equals frequency times lambda. You don't remember?
No, too, sir.
Okay. So we do have the frequency, which is 5, times what is the value of lambda? What is the value of lambda? Check the question on this.
75 millimeters.
They are trying to trick you. If you look carefully, what is the unit of lambda, or what is the unit of wavelength?
Meters.
in meters. So are we given the units in meters?
No, sir.
So what should we do now?
I think we must divide the 75 by 100.
That's true. And the answer will be if we divide it by 100, so you are right. This will be, let's use a calculator and see what we're gonna get. So it's gonna be 5 times 75 divided by 100. We are getting a value of 3.75. What is the units of speed? What is the units of speed?
Seconds. Was it seconds?
No, speed is not measured in seconds. Second is time.
Oh, okay.
Don't make that mistake. What is the units of speed?
Is it meters per second?
That's correct. Okay. What is the distance covered by the wave in 4 minutes? Again, they are still confusing you. They always try not to give you the standard units, and you must be careful with that. You must always be ready to convert units by multiplying or by dividing, depending what the case is. Okay, what is the distance covered by the wave in 4 minutes? What is the distance covered in 4 minutes? So how do we find the distance? What is the formula of calculating the speed? Let's start there.
Calculating the speed.
Yeah.
V is equals to frequency times wavelength.
Okay. Do you agree with this formula?
Yes, sir.
Let me say change in displacement over change in time. So do we have the velocity? Do we have the velocity? Or do we have the speed? Sorry.
Yes, sir.
Which is
3.75 meters per second.
3.75 is equals to, do we have the change in displacement or do we have the distance? Do we have the distance? No, we don't have. That's what we are looking for. Do we have the time? Miss, do we have the time? Are we given the time? If we are given the time, that is going to be very easy.
It's
Just look at the
4
question.
minutes.
4 minutes. Remember, the units of distance is meters per second, but we're not given seconds, we're given minutes. So what do we do? How do we convert 4 meters to seconds? Four meters or 4 minutes to seconds. How much will it be? how much will it be?
Or 240 seconds.
It is going to be
240 seconds.
yeah, but okay, so it's gonna be 4 times
4 times 60.
yeah, that's what I wanted to see because they sometimes do want to see your calculations. Okay, perfect. So this is over 1. You understand the cross multiplication most, eh?
Yes, sir.
Okay, 1 times change in y, it's gonna give us change in y. Change in y is equal to 3.75 times 4 times 60. So what did you get? So how much did you get?
900, sir.
900. And the units? What is the standard units of distance?
Meters per second.
That's speed.
Oh, keep on confusing distances.
That is speed. You must be careful. You must be careful. So that's about it. So let me see if we have any other question that we can try. There should be more questions that we can try to attempt. Let me see if I have something in stock for you, especially in electricity, because I want you to master electricity to the core. Let's see if we have something we can talk about in electricity. Okay. Yeah, no problem. So we're gonna try to do this question. Okay. It's gonna be no, well, no problem. Okay. Can you see what's on the screen?
Yes, sir.
Okay. Consider the circuit diagram below. Okay. Switch S is open. Write down the reading on the following. Voltmeter V1. What will be the reading of V1? When the switch is open. What will be the reading of V1 when the switch is open?
Yeah, I'm not sure, sir.
You are not sure. Okay. So what is the definition of the EMF of the battery? What is the EMF of a battery? EMF. Now the EMF, it is the reading, voltmeter reading when the circuit is open. Unfortunately, what we're gonna read on V1 is simply 24 volts. 24 volts, that's what you're gonna read. Okay, now when the switch S is open, what will be the reading of A1? What will be the reading of A1? The reading of A1, the reading of A1. And also, what is A1? Is it the resistance? Is it current? Is it the potential difference? What is it?
It's the current, sir.
What is the definition of current? What is the definition of current?
The rate of flow inside the conductor.
Okay, when the switch is open, will there be a flow? Let's say, for instance, there's a supply of water and then you decide to disconnect. Are we going to have a flow of water? Is there going to be a flow if the switch is open? Or let me just say, if someone goes and cut off all the cables where you stay, are you going to have electricity?
No, sir.
So is there going to be a flow of current?
No, sir.
Okay. So what will be the reading of A1? If there's no flow, what will be the reading of A1? There's nothing flowing, so it's 0A. Do you agree with that?
Yes, sir.
Okay. Now, switch S is now closed. Calculate the equivalent resistance of the circuit. What will be the equivalent resistance of the circuit? The equivalent resistance is the resistance across the parallel connection. So what will be the resistance across the parallel connection in this case? What is the formula? The formula of calculating the equivalent resistance. Of a parallel connection.
1 over RT is equals to 1 over R1 plus 1 over R2.
Or or the sum divided by the product. The sum divided by the product. Okay, let's see. So 1 over the other one is 8, ne? And the other one is also 8. So what do we get? Did you get 0.25? Did you get 0.25?
Yes, sir.
Okay, so is that the answer? Is that our answer? Please, is it our answer? Is that our answer?
Yes, sir.
You're saying yes.
Yes, sir.
No, it can't be. Remember, we are calculating 1 over RT. 1 over RT equals 0.25. Ne? Now, to
Yes, sir.
get RT, what do we do? Take your calculator and say 1 divided by that and see what you're going to get.
4, sir.
4 ohms. Yazi ndiyacela, don't forget that in this case, you are calculating the value of 1 over RT, not RT. Ne? Okay. Or you can say the sum divided by the product, in which the sum is 8 plus 8 divided by the product is 8 by 8. So what do you get? Sum divided by the product. The sum of the resistance in parallel divided by the product. What is it? How much did you get? No. Actually, it is the product. Sorry. It is the product divided by the sum. Sorry. It is the product divided by the sum. How much did you get? Product over sum. How much did you get? 8 times 8 divided by
16.
8 times 8 divided by 8 plus 8.
Yes, sir.
You got 16.
Yeah, I got 16, sir.
64. Okay, divided by plus 8. Yeah. No, go and use your calculator properly. Okay, let's say what is 8 times 8?
64.
64. And 8 plus 8?
16.
16. So 64 divided by 16.
It's 4.
4 ohms. Yeah, perfect. No problems. Now, that is the resistance of the parallel connection. So what do we do after calculating the parallel resistance or the effective resistance from our steps? We have to reconstruct our circuit. The switch is now closed, it's fine. But then now the equivalent resistance, it is now 4 ohms. Then we have another resistor, which is 8 8 ohms. So now I have two resistors that are in series. Do you see that?
Yes, sir.
Now it has become very easy. The main aim of resolving circuits is to ensure that you find the total of potential difference, the total of resistance, and the total of current. Yes. Okay, now they're saying calculate the reading of voltmeter V2. So how do we calculate the reading of voltmeter V2? Kumis, how do we go about it? We have said that the aim of resolving circuits is to calculate the totals. Once we have the totals, we will be able to calculate almost everything. Okay, V total is given by I total times R total. Do we have the V total? The total supply of the potential difference across the circuit, do we have it?
No, sir.
We do. It's 24. 24, that's what the battery is supplying, because the battery supplies the entire circuit. This is our overall power source. That 24 there is the overall power source, which is going to be distributed to all the appliances or to all the resistors. So V total is 24. Our I total, do we have I total so far?
No, sir.
Okay, do we have the total resistance?
Yeah.
It is how much? Let me go back to the sketch. What is the total resistance of the circuit? What is the total resistance of the circuit? The total resistance of the circuit, you need to add all the resistors that are in series. That will be your total resistance of the circuit.
It's 12.
R2, you see,
Yes, sir.
it will be R1 plus R2. So this will be 8 plus 4. So it will give us 12 ohms. Now you take that 12 ohm, then you put it there. Now your I, if I divide both sides by 12, 12 will cancel. Then I is given by 24 over 12. What is 24 divided by 12? 2 amperes. Ne?
Yes, sir.
Now we have the total of everything. We have the total voltage, we have the total current, we also have the total resistance. The total resistance of the circuit is 12 ohms. Okay, if you have the current of the circuit, how do you find the potential difference across the 8 ohms if you know the flow? Everything in electricity revolves around which formula? Ohm's law.
Yeah.
What is the Ohm's law formula?
I is equals to V divided by R.
Yes. Now, your V is equals to from Ohm's law. Your V is given by what is the formula of calculating V?
V is equals to I times R.
That's correct. Do we have the value of I?
Yes, sir.
Which is
2 amps.
2. Do we have the value of resistance?
Yes, sir.
Which is
12.
you are talking about the total resistance, but V2 is not V2 is across the 8 ohm resistor only. Remember, whatever the battery is going to supply will be divided into the resistors. So we want to see how much will be divided into the resistor. So the resistor, the resistance that we are going to use is 8 ohm. So the current that is flowing through the circuit will pass through the 8 ohm, and it will use 2 times 8, it will use 16 volts. Out of 24, it will use 16 volts. And then the rest of the voltage that is going to come here on the parallel connection, it will be what? Since the total is 24, and from that 24, only 16 volts was used. How much do we have left? Kumis, if we had a total of 24 and 16 volts was used by 8 ohm resistor, this one, it used 16. How much is left or to be used by this one?
8, sir.
It is 8. So how did you get it?
I just subtracted 24. Just subtracted 16 from 24.
Yeah, you can subtract or you can use Ohm's law. You can say agree voltage equals IR. You can say I, which is 2 times the resistance. How much is the resistance here? It's 4. You can say 2 times 4. You will get 8. The same thing. Do you understand?
Yes, sir.
Okay, perfect. How do the reading of ammeter A2 and A3 compare with each other? A2 and A3. How are the readings compared?
I think it's because they're in parallel.
Yes. So, what will be their reading if you compare them? If you compare them, will they be the same? Will they be different? Will the other one be larger than the other? What will be the comparison? you were to choose two queues, ne? And the two queues had the same number of people on them. If you were to choose between the two queues, which one would you opt for? If the two queues have the same number of people queuing, which one would you opt for? If the two queues had equal number of people, I don't think you will be able to choose because both of them have the same amount of people queuing. So even in this case, the resistance is the same. If the resistance is the same, it means also the current that is going to flow on both branches, it will be the same. Do you agree?
Yes, sir.
Since the potential difference across these 2 points is equal, the potential difference is given by I times R. Now, if the voltage is the same and you have the same, what you call this thing, you have the same resistance, it means you are going to have the same I's as well. But that's a story for another day. I think we're running out of time. I was compiling a multiple choice question. Once I'm done with it, I'm gonna share it on the group. So it's gonna be a small test, just to prepare you for the exam. It will be timed, and you can write it in whatever time that you want, whenever you feel like you are ready.
Yes, sir.
And most of the questions you're gonna have to work them out, but it's a multiple choice question. So you can keep also your solutions in case if you don't get it, then you will ask me questions late. But
Yes,
I will
sir.
send the test once I'm done. Okay. Yeah, so that will be the last thing for before you write. So when are you guys writing?
It didn't notify us yet.
Okay, but the test, I'm sure they are very soon.
Yes, sir. Maybe.
Okay. Yeah, no problem. I will see you. Today is most Thursday, so I will see you on Tuesday next week.
Yes, sir.
Okay. Yeah, if possible, you can do more electricity problem so that you can be more familiar with electricity before the test.
Yes, sir. No problem.
All right. Sure.
Sure.